The dirt whacker belt cleaner blades are individually mounted on a parallelogram, which in turn is mounted on a main frame. The main frame's position is determined during the initial installation, and there is no need for further adjustment to the main frame. To compensate for wear on the cleaner blades, the dirt whacker makes use of a single air bladder that services all parallelograms on a given belt cleaner. As the air bladder is pressurized, it exerts force on the inner walls of the parallelogram, thereby providing a precise controllable belt-to-blade pressure. From a convenient location, the pressure in the air bladder can be monitored and maintained as blade wear occurs. No skilled labor is required to maintain optimal belt cleaning with the dirt whacker. Blade angle of the conventional scraper. Maintaining the correct blade-to-belt angle is imperative if excessive spillage is to be avoided. The conventional scraper blade arrangement is susceptible to friction that occurs between the conveyor belt and the blade. The belt-to-blade friction forces the blade into a negative belt-to-blade angle. The kinetic energy inherent in the velocity of the material forces the scraper blade further into a negative angle. A negative belt-to-blade angle acts as a conduit, and material is forced past the blade. To reduce the spillage that is occurring, the conventional scraper unit is readjusted towards the conveyor belt. When the material is removed, the conventional scraper blade will be forced into the top cover of the conveyor belt. Thus, accelerated top cover wear will occur. Incorrect blade-to-belt angle leads to excessive spillage and belt top cover wear. The dirt whacker principle of operation is based on a parallelogram. The durable construction of the parallelogram ensures that the belt-to-blade angle, which is determined during installation, will be maintained throughout the life of the blade. The construction of the dirt whacker parallelogram ensures an extended service life. The nylon-coated hinge pins are sealed off from the harsh operating environment with O-rings. The construction of the dirt whacker parallelogram facilitates trouble-free maintenance. The blade-to-belt angle, as determined during installation, will be maintained throughout the life of the blade. Blade wear of the conventional scraper. Due to the loading pattern on conveyor belts, the abrasive material tends to settle towards the middle of the belt. Over a period of time, the impact of the bulk material causes an array of indents on the top cover of the conveyor belt. The location of the indents reflects the loading pattern. These indents on the top cover act as receptacles for the abrasive carryover material. Accelerated wear occurs as the carryover material passes over the conventional scraper blade. As abrasive material settles towards the middle of the belt, the scraper wear will be a mirror image of the loading pattern. When the conventional scraper assembly is adjusted to compensate for wear in the middle section of the scraper, the outer sections of the conveyor belt will be overpressurized. This results in accelerated top cover wear. Carryover leads to accelerated blade wear and belt top cover wear. The dirt whacker blade system is engineered to significantly reduce blade and conveyor belt top cover wear. The thermal grooves minimize thermal stress on the blade and hard metal insert. The soft metal insert protects the hard metal insert from mechanical and thermal shock. Dirt whacker blades provide a wear life of 15 mm hard metal. Utilizing a rounded leading edge, the dirt whacker blade system can be applied to the conveyor belt at a greater force than the conventional scraper. Making use of the inherent flexible properties of the conveyor belt, all materials, including those lodged in the indents of the top cover, will be squeezed out of the belt, and a clean belt will then be conveyed over the hard metal insert of the dirt whacker blade. If the indents into the top cover are 20 micron or less, and the correct belt-to-blade pressure is maintained, the wear on the hard metal of the blade will depend only on the conveyor belt speed and the presence of mechanical fasteners, and not on the abrasiveness of the transported material. Each parallelogram unit compensates for blade wear. As a single air bladder supports all parallelogram units on a given scraper, the belt-to-blade pressure of all the individual blades remains equal in spite of wear. Each parallelogram unit is able to respond speedily to load-varying conditions. The dirt whacker blade system does away with carryover. The single air bladder ensures uniform belt-to-blade pressure. No skilled labor is needed to keep the dirt whacker functioning optimally. Only the air bladder pressure needs to be maintained as determined during the initial commissioning of the dirt whacker cleaner. Blade height must be verified at regular intervals. The abrasiveness of the bulk material will determine this interval. Replacing the blades is a cost-effective operation of removing the unit by undoing 4 bolts. By making use of the blade alignment tool, the blades are aligned with ease. Installation of the dirt whacker belt cleaner is explained on the dirt whacker CD-ROM by means of video and printable material. As the belt-to-blade force of the dirt whacker primary and secondary cleaners is controlled by air pressure, the dirt whacker belt cleaner units can be remotely monitored and activated as needed. The dirt whacker control units allow for the seamless integration of the dirt whacker cleaners with the conveyor plant PLC system. As a result, the activation and full or partial deactivation of the dirt whacker cleaners can be fully automated. The feature allows for problem-free operation on fast, dry-running belts. Belt top cover wear is significantly reduced if the belt cleaner is not active when the conveyor belt is running dry. The dirt whacker cleaners can accommodate reversible conveyor belts. The dirt whacker primary and secondary cleaners function well on most mechanically joined belts. The dirt whacker product range is successfully deployed on conveyor belts with speeds of up to 6.7 meters per second. The unique technology of the dirt whacker makes efficient belt cleaning available to the industry, with conveyor belts of up to 4 meters wide. Dirt whacker, the company committed to conveyor belt cleaning. A company committed to service excellence in the bulk materials handling industry.